Okay, let's get started. Um, I hope you had a nice break for a couple days. Now we've got just 2 weeks of classes left, and then the final exam week going on. So we'll be going over some new material, but we'll spend a fair amount of time working on the final project now going forward. So one of the big things we have left to do is to work on a final program or project for you. And then we'll also have the second exam during the finals week time slot. Um, so let's jump into Unit 14 here. Um, and today we're going to split our class up into the first half. I'll go over a little bit on unit testing here. This is a section that we don't really have covered in our textbook, but we feel it's very important in software design to talk about it and talk about it early on in Java. So we'll talk about that here. And then the second half of class, we'll have you work on think of what you want to do for the final project and start working on a design document and what that would entail. So by Friday, we want you to have this design document done. And then by next week, Monday, we want the first prototype of the final project done, some semi-working version of it with some limited features set up there. And then the following Monday, hopefully you'll have the completed final project up and running so you can demonstrate that here. So again, we're going to jump into unit testing. So I'm just going to go into the learning material and unit testing here. And again, this isn't covered that well in the textbooks. And so I'm just using AI to kind of create some a description for us. So I'm looking at Google and ChatGPT to kind of explain what unit testing is. So you can read through those. I'll just give you a basic idea. The idea of unit testing. So the idea of software testing is to find errors in software there. The smallest and simplest type of this is what we call unit testing. And software developers generally do this when they write code. So the idea is you write maybe a method and then you write some unit tests to check if that method is working correctly for things. So unit testing are small, little tests that test specific features of your code for that. And again, it's often done by developers here. It's often done in an automated format, and so we'll see that today. Most of the development environments have an automated testing environment for unit tests here. So we'll look at what NetBeans provides for this stuff. Now, one of the goals of unit testing is to try to find bugs early for this. If you get into talk a lot about software development and errors and error detection, one thing you find is that the earlier you can detect an error, the cheaper it is to fix the error there. So like if you're just a software developer and you write some code one day and the next day you write some tests to test out that code, you might spend a couple hours writing the code, a couple hours writing tests against that code, and to find an error and to fix that error. At that point, it'll just maybe cost you an hour's worth of work there. So maybe $50 or $100, maybe $100 worth of time there to find an error there. But if that error goes out and a lot of other developers are testing it and other developers are running code against it, and some other developers spend time running it, and maybe you have some beta testers out there who are running it, and they find some code and you have a QA, an actual tester that's finding that. And again, a number of people are seeing, trying to figure out this error and trying to figure it out. That might be costing you $1,000 and might be a couple weeks later, and it'll cost $1,000 worth of time and effort to find that error there. But if that error isn't caught and it goes out to your customers and released there, and your customers do it, then your customers run into problems. The customers then report back issues to and file complaints and stuff. You may lose customers. You may certainly lose a lot of time trying to track down these errors. When it gets out to customers and stuff like that, often that's a $10,000 error, and if it's critical, it could be a $100,000 error for us. So it's much better to catch the error when it's only takes $100 to fix it rather than $10,000 to fix it later on. So that's why we want to do unit testing to kind of uh, check or fix these errors early. Um, Another area is refactoring, and we'll talk more about refactoring in a little bit, and allowing us to redesign code more confidently here. So now there's different frameworks for unit testing, and it's different environments have different things. In Java, we tend to use something called JUnit for Java unit testing. Very creative name, JUnit testing here for writing tests. And we'll tend to write and run those tests a lot for things. And we'll talk about this refactoring and iteration stuff. No, we're just talking about unit testing, but that's actually the first part of the whole framework of testing. We test the individual units, then we put the software together, and we do what's often called integration testing. We often then want to test these on different systems. So there might be like system testing. You might have maybe a website or software that runs on phones. You try it on phones of different sizes, different types, different brands there, and do a lot of testing there. So there's actually a whole area of software testing out there. It often goes under the name quality assurance. So I would like you to try to find a quality assurance or a testing job out there. So see if you can, I don't know where you like to look for jobs. I tend to look at like LinkedIn, but you could just go to Google and type in quality assurance jobs. Hmm. And maybe pick your favorite location. I'm going to look for maybe in Denver. And I'm going to skip over all these sponsor stuff. Just go down to this Google job listing area, and it'll list out a bunch of quality assurance jobs for us here. Uh, okay, or you can again go to LinkedIn and look at the jobs in LinkedIn also. So why don't you find a quality assurance jobs? Again, they'll be sometimes they'll be called different things. They might be just called testing or test automation or tester jobs. They might be called quality systems, quality assurance sorts of jobs here. See if you can find a quality assurance job. I don't care where it's at necessarily, but see if you can find a quality assurance job here. All right. So again, here's example is quality assurance engineer is the name of the title. This is in Denver. And again, responsibilities, here's the ones I like. Develop and execute a comprehensive test plan, test cases, and test scripts for digital campaigns, including email and landing pages. So it's a web looks like one. And again, they want a bachelor's degree generally for this. All right. Someone else who wants to share a testing or quality assurance job that they found there. Uh, you used to do QA? What did you do? Test games? For which? For Steam. Yeah, so I mean, so not for the because Steam is they bring you like I didn't know they made games. I thought they mainly just you know okay. Uh-huh. Okay. And you had a list of what you were trying to find, what area you're trying to test out in those games? Okay, right. Interesting. So, all right. Can someone else give me an example of a QA job or a testing job they found? Yes.
Like culture that comes up is about impact companies and how the job is responsible for doing like the final inspections on like the aircraft.
Okay. So that's a quality assurance job, but that's not necessarily software. It sounds like that it's in a different field. Interesting. Yes. So more aircraft checking sort of jobs. So how about one more? Okay.
It's a senior software QA engineer.
Senior QA, software QA engineer. Okay.
The company is Linguistic Information Systems
Okay.
LL.
Can you give me either a description or what they do or what they require, what kind of
So the location is in, I don't know if I pronounced it wrong, Pleasanton, CA,
okay, yep.
and then okay, education, CIS, and it's IT, BAS, Dev, Gen. I don't understand anymore.
Right, yeah.
And then it says SQL,
So yeah, so you should know SQL, okay, JavaScript, Ruby.
and Pro.
Okay, so a number of different languages and stuff like that. Okay,
Using data function, use web object technique,
all right.
Python.
Yep. So a variety of languages too. All right. Okay, thank you. So again, you can decide that. I don't like software testing. I don't think I never thought I'd enjoy these sorts of jobs there. But again, one thing I always think about is when you play video games, if you play video games and you run video games, you like to do lots. Do you like to try to check off all the stuff in a video game? Do you like to try to get all the side quests done, all the objects, all the badges? You just like to are you very organized and efficient and keep track of things? If so, QA testing might be the way to go. I just don't think I have enough pay attention to detail enough to be a good QA tester and enjoy that process there. Uh, so again, let's talk a little bit about unit testing here. We're going to talk about these test suites and the setup here. Well, I'm going to go down here. So this talks about some sample unit tests here. And so what we do is similar to normal software, we write a class here. And here's two different examples. And then inside the class, we have methods, and each method is a different unit test here. So we'll have a different unit test. And we'll set those up to run. So to see that a little better, I'm going to open up this project. This comes from our practice projects where we did a number of projects that involve, or one of the things we did was breast cancer detection. You ask the user to enter the radius of a tumor and then the concavity. And based on that, you try to check if the radius is greater than this and concavity is greater than this, then it's malignant. Or here, there's three ways it could be malignant. Otherwise, it's a benign tumor. So it's either cancerous or not here. Now, we started up with some sample code here. Where we'd ask the user to enter the tumor radius. And again, when we're learning to do loops, radius had to be in a certain area. It had to be more than or 0.1 or more and less than 25 millimeters here. So we had a loop here that if they entered something that's too small or too large, they ask you to re-enter it in the range. We keep looping there until they entered it correctly. Same with concavity. We ask them to enter that, read it in, and then again, check if it's in some range here and keep looping until they enter it into the legal range. And again, then we have these if-thens to check if it was malignant or benign, cancerous or not here. Now, when we write code like this, it's all on the main one main method. It's really hard to unit test. So instead, we're going to break this code up into methods and test out individual methods. So we'll have a method for entering the tumor radius, another method for entering the tumor concavity, and another method for checking if it's malignant or benign here. So that's what we have here in this GitHub. So I've taken that and brought it and done my team import or clone and opened it up here. And here's that same kind of code here. Here's our main method. And we're calling other methods. We're calling read radius that reads the radius and has the loop in to read the radius. Read concavity reads the concavity and has that there. And then we classify the tumor. Here's our if-then statements. And here we're just returning either malignant or benign here. So we get that, and then we print off the tumor is. So when we run this, so if I run this normal, this doesn't run the unit test. It just runs it like we normally have. Like enter some tumor size, so maybe it's 5.2 radius, and the concavity is 0.24 there, and that's a benign tumor at that size and concavity. Okay, so that's my code. Now, I don't know if you can see on the left here, this is our package. We opened it up, source packages here, there. But I don't know if you've noticed, there's always also been some other packages or folders here. And one's called the test package. And we really haven't looked at it. In fact, all of our programs have had that there. There just hasn't been anything in it because we've never put in unit tests. But now in some of these, we'll see here going forward. So if I look under test packages, there's this test stuff. And so again, it's just a class. And inside that class are some different methods that run different tests here. Now, each of the tests has what we call an annotation. It has an @ sign in it to annotate stuff. I don't think you as programmers have in Java have seen annotations yet. I think this might be your first @ again. So we've seen imports there. We've seen comments, but I don't think you've seen these annotations. So what's an annotation? So far we've had code and we've had comments. Comments are notes to the user, to the, to humans about what the code does. And the computer ignores those there. And then the code is that that's the stuff the computer actually runs for this. Annotations are kind of in between those. They're notes both to the humans and to the computer about the code. So they're not code, but they're telling us something about the code there. And in a lot of places, they start with an @ sign here. And so we designate tests here. And if you go on to do more software development, you'll learn more software annotations for different things here. But this is your first time. So that's why it's showing here. We generally use this @ test annotation to annotate our tests for this. Okay, so I'm going to jump down here to the bottom of the tests here. And here's a test. So again, it's a method test classified tumor here. And you can set up the tests any way you want, just like you can set up programs anywhere you want. But a common way of doing it, and one we teach in a lot of our classes, is the AAA method: arrange, act, and assert. So all of our unit tests will have those three sections. An arrange will set things up. So we're going to try set things. We're going to say, okay, here's the radius we're going to test out. Here's the concavity we're going to test out. And here's our expected result. It should be benign. So our arrange is kind of to set stuff up here. Our act, we will call our classified tumor method, whatever, we do whatever we want to do. Here we're calling classified tumor. We're passing in the radius and the concavity and getting the result. This should be benign or malignant, one or the other there. So that's our act, is we do what we're going to test. And then we do an assert, and our assert checks. Now, this is a new statement here. We haven't seen assert statements anywhere. So we have a bunch of asserts and different types of asserts, but common ones are like assert equals or assert true, where we are testing if something is true, or we're asserting something. It says this should be this, and if not, the test should fail, basically. So that's what our test is that every test should have an assert here. And here we're just asserting that the expected result and the actual results are equal here. So we set the expected result as benign. Here's the actual result, and we're asserting that they're equal. Now, how do we run these tests here? So if I scroll down here, there's a couple ways. You can choose run test project. So again, so far we've been just clicking run here, but that doesn't run the test. If I go to run, there are two options under run project and run test project. So I can choose run test project, and it will run the test projects here. Now, notice it says test finished. Do you want to open the test results window? I'm going to say yes to that here. And here's my test results window. I'm going to move that. I think I'm going to move that down. Maybe I am. I'm going to move that down here with my output. Um, and again, you can also just see if you go to Windows IDE test results, that will pop it up also for us. And again, here's where we can run our tests for us, and we can see what tests are showing up for this. So again, it ran all of our tests, and again, we can rerun our tests anytime we want. I like to show, you can show which tests are going to be visible. I like to make sure that all the tests, even the past ones, are showing up here. And then I can open this up and see all my tests here. And the idea here is that if a test isn't passing, it'll be red. So let's say I made a mistake in my code. So I'm going to go back to my code here. For example, I'm reading in the radius. The radius can be more than, or it can be 0.1 up to 25. But it can be including those values. But what if I actually put in an equal here and maybe an equal here, where I said if it was less than or equal to 0.1, then I will ask them to redo it here. So if I do that, if I made a mistake in my code and I run my tests, I should get an error. So again, one of my tests fails here. I can look at it. I can see the problem here, and it will point me to where it's at for this. So again, we'll talk about this red, green stuff. When you first make changes to your code, you'll have some often code in or unit tests in red, and then your job is to convert them to green, to passing for this. In fact, like in my software design class, my advanced class, sometimes I'll just give them a project. Like right now, they were just given a project with a bunch of failing unit tests, and their job was to fix get all the tests to pass. When you're a beginning developer, that you will, before you know so much, it won't be, you might be given your manager or your mentor or whatever might say, okay, here, I'm going to write some unit tests. They're going to fail. And your job this week is to redo the software so the unit tests pass here for this. So again, you'd go in here, you'd say, oh, this unit test is failing. You'd see what the unit test is. You say, oh, this, is a unit test for, we're just entering point 0.01 here for that. And we expect the result to say that 0.01 is a good test radius here, but it's not, it's failing. So you might look through your code and say, oh yeah, I can see I should just do that instead. And then you rerun your code, rerun your tests, and now they'll all be green. Yay for this. Okay. So again, I mentioned the assert statement here. And there are different versions of the assert statement. We're not going to go over that too much here. I mentioned this format, the arrange, act, assert. We set things up in the arrange, we execute the code we want to test in the act, and we assert something about the results or the outcome when we're done here. So that's it. We'll look at something called red-green refactor on Wednesday. So Wednesday we'll do this POGL activity in groups where you'll have to take some code, write unit tests that'll fail, and then you'll have to correct those. So we'll do this red-green refactor activity on Wednesday to learn more about it and have you actually try out some unit testing. Okay, got enough for unit testing today? Ready to start thinking about a final project? So the second half of class, we're going to have you think about a final project here. Let's just talk a little bit about the final project. I'm going to go into the final project description here. Uh, so you've got a program, just create a fun little Java program that does something interesting here. You can do any sort of final project you want for this. To get full points, you have to have 25 points of functionality here. So here's some ways you can get that there. So again, try to get, so what we're trying to do is I'm trying to get you to make a complex enough program here. So these are your different points you want to try to do. If you use a while loop or multiple loops or random numbers or a method there, all those things will get you points towards this. So you've got to have a program that has at least 25 points worth of work for this. We're going to start with our design document that's due Friday and prototype that's due on Monday. And we're going to try to work with this iterative design thinking process. You may have seen this, I can see it's principled or whatever, where we're going to want to try to think of a problem we want to solve, something we might want to do to help someone, define it here, and then get some different ideas. We're going to create a prototype this week, test it out, and then we're going to refine that next week and go through this process again for us. We'll just go through basically this cycle. Although one thing we want you to do initially is also kind of think of do this on kind of paper initially, and then we'll try to do it more on the computer for us. So we'll try to work through this process with our design document first. So what are some ideas? There are thousands of different projects here. One thing to keep in mind is you can't do that much yet. You're just Java 1 students. You got to try to scale things down and keep things relatively simple. So initially, we're basically just working with the console interface here, where again, we're displaying things to the screen, and asking you to enter input and stuff like that. So that has to stay pretty simple there. Friday, we'll talk a little bit about could you add a GUI interface, or maybe it will be next week, to this. But initially, we're going to make a just try to keep it to a basic console interface. So games, some of the simple games we've tried, and we've tried different simple dice games. We did Yahtzee, we tried the Magic 8 Ball, tic-tac-toe, some of this stuff here. You've got to be careful here because, like tic-tac-toe or knots and crosses, you can display that and have a user maybe play that, but you certainly can't play against the computer. We're not at the point where you can program a computer to play tic-tac-toe against the user. So, but you could have two people play tic-tac-toe against each other, possibly, or something like that. So is there some simple card games like playing blackjack or something like that gets very hard, but we can talk about doing something like that. But word guessing games work real well. I think we started and did a little bit with Wordle. Did we at some point did that? So some of those are okay. We're good at simple calculations, so calculate your tip, calculate your golf score, calculate your bowling score, calculate, your running pace and your, calories. So, is there some hobby you like to do? Do you like to run and track your information there? Do you like to cook and track, your vitamin intake, your protein intake and stuff like that? Do you like to shop and you have a to-do list or a shopping list? what do you like? What, where your interests lie here? And can we, we can often just keep track of stuff, check things off, create a list of things, stuff like that works pretty well for this. Um, then just other things, calculate student stuff, GPAs, or keep track of your class schedule, something like that, uh, are possible out there. So start thinking of this, what you might want to do for this. Questions on what's required for the final project? So again, we want you to be working on the design document now. What does this app do? What problem are you trying to solve? What input does it need? What outputs does it provide? And again, maybe try to draw out on paper or type out on paper what a sample interaction would be to it. When I run this, like here, before I even code, this one asked me the tumor radius. I can enter that. Asked me the tumor concavity. And then tells me if the tumor is benign or malignant at this point. So that is just a real simple input or output or design stuff. So think about that. How would this look like on paper here? But again, here, if I run this again and I enter an illegal number, it'll give me an error until I enter a better number. Same here, if I enter a legal number. Okay, so I'll pause this. I'll come around and talk if you want. If you want suggestions, brainstorm. I can help you brainstorm, but start working on this now.